We're now at the second stop. We are still looking primarily at the San Diego Formation. So we have some information to learn how old this formation was and what kind of environment it was, but we can also use other clues to get dates for ages of other formations around here. And so, however, it helps if those formations are in some way, shape, or form in contact with one another. So the San Diego Formation, if you look way up the top of that cliff there, you notice it goes from kind of a light brown to a darker brown. That darker brown is a different formation known as the Bay Point Formation. You also, when you see the Bay Point Formation, you'll also see it's much finer grained. It too will contain shells, fossils, though different shell fossils. And now what we're going to do is take a close look at the contact between them. And that what you'll see on this trip is not just that contact, but also the contact between the this and another rock unit, the Scripps Formation right over here. But we're first going to focus on the San Diego and Bay Point Formation contact. So let's take a look, see what we can find. All right. Perfect, yes. Yep. Wow, things have changed on here. So, a couple of things I'm just going to point out as we start climbing is you should notice a very distinctive tilt to the layers that has been apparent in all the photographs you've seen of the San Diego Formation. We're now going to look at, I want to compare this sort of general tilt of the layers to what we see in the Bay Point Formation. Is the Bay Point Formation more horizontal or less horizontal? And I'll get you some better photographs of this shortly. But the reason I came up here is not to compare the horizontality of these layers, but to compare the show what the contact looks like. And so you have something interesting here. At the top here, as you move up the San Diego Formation, it looks just like the sandstone you've been looking at this whole trip. But then you get far enough up, you start seeing these things here. These little white vertical things. Just keep going higher, then you go in the Bay Point Formation, and the top of the Bay Point Formation is probably muddy, but you see quite a bit of cobbles in the bottom of the Bay Point Formation. This is what is called a flooding surface. The way to explain this is that when you have an erosion event, that usually takes place when the formation is above sea level. If a formation starts sinking back into sea level, new deposits can be laid down on top of it. So what you're looking at here is these white things, which we'll get a better pictures of, are probably part of the solar formation. This is probably a caliche horizon we are looking at. Possibly, maybe some roots or something like that, possibly, or root casts, water going down and turning into calcite, precipitating calcite along some roots in the system. Then as you go up, this flooding surface represents the first time this region was underwater after being above water for a very long period of time. And so the reason you see these cobbles, this flooding surface up here, is because these cobbles is that whatever event first puts this underwater is probably going to be a very high energy event. Some sort of storm, some sort of flood. Think of like winter storm, maybe a tropical, maybe a hurricane. The hurricane, maybe an El Nino, but something that caused a large area of coastal flooding to take place. And it's going to wash a lot of cobbles up here. And you can actually see multiple flooding events punctuated by more calmer events in the alternating layers of mud and conglomerate up here. And so we call this sort of contact an unconformity, meaning that there is erosion. Erosion, and there's a gap in the record. We'll give you more information in your activity about just exactly how much time has elapsed between these formations.